Hello, my name is Stephen Thomas, and welcome to the channel. In this video, we're going to walk through an autonomous AI agent that I created using Logic App's Agent Loop. Logic App's Agent Loop is still in public preview, so things might change or look different by the time you actually watch this video. I'm going to walk you through how we created the Logic App, how we made it autonomous, and a little bit of a trick of how to find out what's going on inside that Logic App. We'll take a look at running the Logic App and seeing its execution, as well as the different tools used throughout the agent in order to complete our task. This autonomous agent is going to be designed to play card games. While it might not necessarily be an enterprise scenario, it's a great way for you to learn how to use Logic App's agent loops, because everyone knows how to play different card games. With this, you can pass in any card game, and the agent will know how to play that game. This is a great way to learn how to build your agent and refine your agent instructions. So with that, let's jump in and take a look at this demo.
Now let's dive right into this Logic App. I've created a Logic App here using the new Agent Loop agent processing inside of Logic Apps, and this is currently in public preview at the time of this recording. Now I'm going to dive right in and show you some components of this agent loop. If you want to learn how to do this step by step, I have a step-by-step video below. It's about 30 minutes long. It takes you through beginning to end of how to set up your very first agent loop Logic App. So follow that if you're looking for detailed instructions. And with that, we're going to jump right into this Logic App. So this is an autonomous Logic App, which means I expect it to be kicked off and run completely without any user interaction. Now that is set up under your agent here under channels. You would simply select do not allow channels, and channels is how you would interact with this agent if you did have user input. So if I wanted to get responses from the user, such as selecting a specific record before it continues to process, I would select a different channel option. In this case, do not allow channels. So this is going to be started via an HTTP request, and this request is going to pass in two simple things. It's going to pass in the game to play, which could be any card game, and it's going to pass in the number of players that we want to have in this game. Now, the reason I chose a deck of cards, a card game, is it's very easy to understand and very easy to model inside of an AI agent. Plus, it was one of the connectors that required no signups and no API key to be able to leverage. So I'm using this deck of cards connector inside of Logic Apps in this AI agent. Now, this isn't necessarily an enterprise scenario, but it's a very great way to jump in and start playing around with agent loops and learn how to better build your agent loops overall. Now, the number one thing I found when working with these types of agent loops is I need to constantly refine and update my agent instructions. And that's what tells the agent what we're going to do in our agent process. And I found one little tip here that even though this is an autonomous agent, I still return a response. This response is going to be the last agent message. And this is just a real easy way for me to tell what's going on with that agent process as I'm testing and debugging this. Now, a lot of times I still have to jump in and look through the run history, which we'll take a look at, but a lot of other times I simply don't and can read by these agent instructions that something has went wrong. So kind of the guts of this whole process is going to be this agent instructions here. Now, if you follow the blog post as referenced below, I have these agent instructions posted there in detail. You can simply take a look at them and read through them. We'll take a quick look at them over here in Notepad. Now, these agent instructions have been refined multiple times over the past few weeks as I have been working through this. My first set of agent instructions were just a few set of bullet points. I took those bullet points, put them in another AI tool, in this case I used Gemini, and asked Gemini to refine my set of agent instructions to be better agent instructions. So that was kind of the base that you see here, these agent instructions, actually generated by AI itself, which is kind of cool. And then as I find problems, I come in here and update this as I go through and execute multiple runs of this AI agent. A few things I did want to point out here is service call reliability. So I found occasionally I would have a service call that would fail. So I simply made it as part of the operation of the agent. If a service call fails, retry it up to 3 times. And then make sure you tell me in the final report if you retried any of your service calls. So I thought that was kind of cool. So I simply added retriability just right here in agent instructions. And then step 28. I call a card shark, which I'll talk more about in just a second. And interpreting the response from the card shark, sometimes the responses would add extra text segments coming back. It was kind of hard to parse that JSON. So rather than parse it in a action inside of a logic app, I simply said, look in content dash text segment for its response. And the AI agent is smart enough to know that if there's blank text responses, that's obviously not the response it's looking for. It's looking for the results that the card shark would tell it to do, and it knows which one those are. So simply refining these agent instructions has been key to making sure this AI agent will work for pretty much any card game that you want to supply. And you can see some of the other things here, unknown or rare games. So if you pass in a game called like Pizza Hut, for example, it would say it's unknown or rare and not try to play a game that it just kind of makes up. So I added that after some testing as well. So let's dive back into the logic app here and take a look at kind of what we set up here. And in no particular order, these are our tools that we have set up here inside of our agent. And the first one's going to get a new deck of cards. You define the description for what you want that tool to do. In this case, it's going to shuffle the cards and return a deck ID. That deck ID is going to be used throughout the whole process so that we can ensure that we're all dealing from the same deck of cards. And not much there. And this is simply the shuffle new deck connector, which is the deck of cards, which is a third-party connector, which is available to us inside our 1400 plus connectors that we have available inside of Logic Apps. Super cool. So I simply use that for this demo. Simply walking through here, the next thing is going to be email results. So at the end of the game, I want it to email me with the results of what happened in the game that it played. Simply called email results here. And these use agent parameters here. So I have body, subject, and to, and these are defined as agent parameters. And this is so the agent knows what parameters this tool is expecting. So in this case, I'm expecting a body, a subject, and a to, and this is just simply set up here with a description of body of the email. That should be email. Go ahead and fix that. And that's going to call this send email action that I have set up here. And it's simply saying to, subject, and body, just as we would expect an email to have. Continuing through here is dad jokes. This again was a connector, third-party connector that required no API key or authentication. Simply going to call and get a random dad joke. I'm only going to call this if the player one, who is the computer, wins the game. Again, this was just here to show you how you can use agent instructions to kind of dynamically call different content. So it'll return a dad joke if the computer wins to, make the other players feel better. Now I have Card Shark. Now, the Card Shark is a tool that I added just to make sure the AI agent is doing everything correctly. Now, this actually is a call to OpenAI, and in this case, I'm calling one of their reasoning models. Now, I want to do this because I think the OpenAI reasoning model could do a much better job interpreting what cards I should hold and what cards I should fold in something like a 5-card hand draw of poker. So I simply call OpenAI and I format this request coming in, and it's going to call the O3 mini model. And I simply say I'm using the game to play, which is not an agent parameter. This is a passed in parameter from the top, actually received in my HTTP request. And then I'm going to use this agent parameter here, which is the player's hands of cards. So it's going to call this each time for each player, passing in the individual player's hand. And I'm simply going to ask this large language model what I should do to optimize my chances of winning this game based on the game that I'm actually playing. So as part of this Card Shark in the agent instructions, it also outlines, well, only call Card Shark if you need to. So if I'm playing a game like High Card Wins, there's no need to call Card Shark because there's no optimization that needs to be done. Again, I'm using those AI instructions, those agent instructions, to determine what to do in this process. And then now here I'm using a stronger model, this reasoning model, to better ensure that I'm going to get the right outcome of this call. So along with that, I also have this rules of the game tool here, which now the AI agent was doing, the default agent here is ChatGPT 4.1. It was doing a pretty good job determining the rules of the game. But what I found when it was a game it didn't know, such as Pizza Hut, it would say, oh, that's an obscure game. We're just going to try to play something. So I want to better search the rules of the game to ensure that it's playing correctly. So again, I'm going to make another call to an AI model. In this case, I'm calling an OpenAI model again, but I'm passing in something a bit different here. I'm simply doing a web search, and I'm passing in, this time as an agent parameter, the name of the game to play. And I simply tell it here that if it doesn't know, if it can't find that game, if it's not a real game, say unknown. And if it's a little known or harder to play game, then simply return rare. And in my agent instructions, I have instructions on how to handle this when that happens, this unknown and rare scenario. So again, the default agent running the agent loop did a pretty good job with this, but I just wanted to make sure it was more well defined. So I'm going to do my own search to come up with that. And then the last thing here is I'm going to compose the rules of the game, just formatting the response a little bit better there. Once we get the rules of the game, we can check who won the game. So this is going to be done a little bit differently too as well. In this case, I'm going to call a DeepSeek model, a DeepSeek reasoning model, just for the show you how you can interact multiple LLMs inside of a single agent. Is what we're doing here. So I define a system role here. It says you're a master judge of the card game, and I want you to, determine who won the game. And this was again just to kind of do a double check. And these are using agent parameters, game to play, the final hand of each player. So in this case, the agent is going to know after it's done any dealing of the cards and drawing of the cards, if the game permits drawing, it will call the final hand to determine who won the game. And I'm going to have both the AI model running the agent and this DeepSeek model results, and it's going to compare them to make sure they're correct. Now, this came about because I found the model wasn't necessarily very good at checking for straights and flushes. So what it would do is say, oh, I have 4 cards to the straight. Let's go ahead and draw for the straight. And if it would get that straight, if it would actually complete it straight, it would say, oh, I have nothing. There's nothing here. So I have updated the agent instructions, of course, to include check for a straight, and gave an example, and check for a flush as well. But I just wanted to have a double check here to check who won. And for the sake of the demo, I just decided to call DeepSeek so we could see a different example of, again, another LLM being called here inside of this agent process. So this is going to call into a DeepSeek model. Now this model is actually hosted in Azure. It is the DeepSeek model, but it is a model as a service. So it's pretty neat that you can call these DeepSeek models, but still have some safeguards in place that Microsoft puts on top of that model. So this is actually that DeepSeek model as a service. Now the fundamental piece here, draw a card. Again, the tool descriptions here will kind of outline what's happening in this process. It says only draw the card if you need to. So in the case of like high card wins, it wouldn't have a reason to draw a card. So we wouldn't expect draw a card to be executed in that scenario. When we do call this, we need the deck ID and number of cards. So I expect the AI agent to determine the number of cards need to be drawn. So like for the first round of draw poker with 3 players, 5-card draw, I would expect 15 cards to be drawn, for example. Again, using that deck ID from the first tool that we saw where it shuffles the deck. So that's kind of a high-level overview of these different tools that I've supplied here to this AI agent. And again, the agent instructions are going to tell it, kind of how to play the game, how to use these tools to accomplish the task of playing a card game. And you can see here as I kind of walk through these different tools, the card game is a very good scenario to work with for one of your first agents because there are so many different options here. Sometimes you draw a card, sometimes you don't, and it gives you a lot of chances here to play around with this. So let's go ahead and jump over to Postman. And let's go ahead and just play high card wins. And high card wins, let's going to go ahead and say 5 players. And I'm going to go ahead and kick this off. Now, part of this process is at the end, it sends an email. Didn't know the best way to kind of see it here. You will see it here under the response history because I do output that last agent message. But I just figured the email was kind of nicer to get a nice, clearer way. It does include a nice graphical image of the cards that is drawing as well. So it generally takes about 45 to 60 seconds for this to run. And I'm going to pause here for just a moment and jump back once this is okay. Now that's completed, and you can see that I have some results here. Let's jump over to the email. It's a little easier to read, and it simply says, was high card win, 5 players, and here's the cards that I drew for each player. You see here, it looks like player 4 should be the winner. If you look at it right, you can see here that it says no cards were drawn or replaced. Hands were dealt in accordance to game rules, 1 card per player. Manual evaluation said player 4 has the highest card. I did do that double check, the service double check. Now this is obviously a non-deterministic process. I didn't outline really how I wanted the email. So every time we get an email, it's going to be formatted a little bit differently. Text is going to be phrased a little bit differently as well. It does say it is checking for straight flush, not applicable since it's just one card per game. And then it says the outcome, player 1 did not win. So that was good. And it does say player 4 has the highest card. So again, I gave it very little instructions of how to play. I gave no instructions of how to play this game. And it came out with all of this reasoning on its own, that who is the winner, how to play, that it one card per person, and that a lot of logic here. You can see in this outcome here that there's a lot of reasoning and a lot of thoughts that the agent has done in this process. So that's, again, why I think this is a great way to get started with this. So let's look at another scenario. I'm going to say too many players. Again, I've not put any instructions in about how to play. I'm going to say there's 60 players, and we're just going to kick this off, see what happens here. Again, it takes about, this one, 30 to 45 seconds, so I'm going to pause and I'll be back in just a moment. Okay, and now we can even see here that it says the game was not played. Let's jump over here to the email. It says, unfortunately, high card wins cannot be played with 60 players. So again, the AI agent knew itself by its logic and its models that it was calling that it couldn't play this game with 60 players. So again, I put no verbiage in there to check for number of players or anything like that. It simply knew that it couldn't play this game, which again was super cool. And although I will say, one time I did, the agent came back and said it had drew a new hand for player 1, the computer, to try to improve its hand, which I thought was pretty sneaky of that AI agent. So I did have to make sure I put in that rule to make sure you follow the game rules. So even though I said, get the rules of the game, I said, make sure you follow them. So, and since then, I have not seen any problems with that. So again, just how you could refine those agent instructions. So now let's jump to something that's more complex. Let's go to a 5-card game here. And I'm going to go ahead and kick that off. 5-card draw, 3 players. And in this case, while that's running, I'm going to jump back here and show us some of those past runs that we looked at. I do want to save this because I did fix that email that was in there. And let's jump back over here back to my playing cards. And let's go to run history. And we'll see this is the current run that's running now. This was our past run where it determined it couldn't play high card draw. It simply says in the chat here, you can go through and see all the executions. So my default agent, first thing it does, get the rules of the game. Next thing it did is emailed results because it knew right away by the rules of the game it wasn't able to do anything here. So then it simply ended. So that was a pretty simple process. Let's look for this one below here. This one was we actually played the game as we expected. And this agent chat over here, now remember we did select autonomous agent with no input and output channels, but you will still get your agent chat over here. So we'll still see some instruction about what's going on. You can see the individual steps here. So like we can jump right to check who won the game, for example, and you can see your input and output. So it gives you a really good, easy way to diagnose what's going on here. If you wanted to see step by step what your agent was doing, you can dive right in here. You can click on it on the right over here under agent chat, or under default agent, you can scroll through it over here as well. Here's the call to draw cards. So what we have 5 players. So it did call in and get 5 cards, exactly as you would expect it to do. Now let's see if our more complex process is done yet. Now this longer one to play a hand of 5-card draw takes about 2.5, 3 minutes. It's about 45 seconds per call for the OpenAI call to the reasoning model, and that is going to double check, what we should do on handling that hand. So we'll give it just another second here. While that's continuing to run, I won't pause it this time, but I do want to jump over to my AI Foundry. So AI Foundry is an important piece of Logic App's AI agent loop because it is the model that is being run here. So you can select different models, but it does have to be an Azure OpenAI model at this point. I simply went with GPT-4.1 because it's the latest and greatest. You could select a different version if you would like. Input cost for this is, I think, $1.50 per million input tokens and $8 per million output tokens. Now, those token costs can come into play if there's something that's running, 100 times a day, for example, versus something like our demo here, which runs just a few times a day. Now, this is just AI Foundry. And if you want to see what's actually happening here, you can go to monitoring. And this is going to give you a view, I think it's pretty real time, into what's going on. So the last 7 days that I've executed this model, So this model is used for all my AI agents. So it would be not just my card drawing agent, multiple ones here. So we can jump over to today, and here's my total amount of tokens that I've passed in, and you can see it broken down as input tokens versus output tokens, and it tends to be about 95% of what we're doing here is input tokens, which is good because they're the cheaper side of the token input. And if we want to look here, it says the average call per request is going to be around 6,000, and if we look over here, we should be able to get an idea of some of these requests. So total input tokens for our last call here, last little session point here, was around 47,000. So in my testing, this agent seems to run around 50,000 tokens per total execution of the agent. So you get about 20 runs for 1,000,000 tokens, and given that it's 95% input, that's going to be your $1.50, and your smaller subset is going to be at that $8 range. So it's not necessarily a trivial amount of money, especially if you're running this 100 times a day. But from what I've seen, the ROI on these AI agents vastly outpaces the cost of these tokens when you pass them in here. And that also points out that you could use a different model as well. So that's one thing I haven't really looked at. My AI agent execution is using models that might be cheaper down the scale. So even at something that might be $2 per million output tokens, and 50 cents or a quarter input could drastically change your costs of executing your AI agent. So my playing card game should be done by now. We're going to jump over here. It has succeeded. Let's take a look at the email that it sent me for this process. And in this case, 3 players. So player 1 really didn't have anything except ace high, so it did what we expected, discarded 3, redrew 3, and got a pair of aces, which is good. It says here, has the outline what Card Shark said to do. Card Shark said to hold the ace and discard the rest. To me, that seemed like good logic as well. Next player had a pair of 5s, which Card Shark said, keep your pair of 5s, draw 3 new cards. Actually didn't improve its hands, it ended with the pair of 5s. And player 1, original hand, a pair of 7s. And Card Shark said, keep the 7s and redraw. Exactly what happened. And it didn't improve its hand any on that as well. So this case, the results: winner player 1, which was the computer, with the pair of aces. Winner verified. Both their evaluations and check who won both said winner with pair of aces, which is fantastic. Just rehashing the recommendations and the results here, and double checking that there was no straight or flushes, just to make sure that wasn't there. And since player 1, the computer won, it does in fact include my dad joke, which is exactly what we would expect. And let's jump back over here. We'll just show what this looks like in the execution window here. And again, our agent chat will walk through and show us the different steps here. You can see it calling Card Shark for each of the 3 players, which again is what we called out for it to do in the agent instructions. And then it comes back to draw a card after it does execute this for each agent, and it did need to draw 10 more cards for all 3 of the players. So it simply did that in a batch and assigned those to the users. And made sure that it called the check who won to make sure we had the correct person winning the game. So again, not necessarily enterprise example here, but a great way to jump in and get started with these autonomous AI agents. Definitely recommend this deck of cards connector. It was really fun to work with. Agent instructions, follow the blog post in the link below if you want to see my agent instructions, and you'll be able to copy and paste them right out of the website and modify them. Again, like I said, I use Gemini to help modify those instructions and make them better than what I could have came up with. So with that, we'll conclude this demo and first walkthrough of agent loops in autonomous mode. And if you like this video, don't forget to like and subscribe. Thank you.